relates to the real numbers is we've got rational numbers, integers, whole numbers, natural counting numbers, and then over here, of course, irrational numbers. So natural counting numbers start with 1 and they go to all positive numbers through infinity. So 145, 5,822, the square root of 4, for example, because it's 2. The cube root of 27 because that equals 3, and so forth. Even like 6 over 1 because that equals 6 or whatever. So those are all natural counting numbers. So you want to actually evaluate these square roots or cube roots or simplify fractions to make sure that they all go in their natural counting numbers. So it'd be 1 all positive whole numbers 1, 2, 3, 4, 5 into infinity. Okay, whole numbers would be all of your natural counting numbers and the number 0. The only number that is not a natural number in this whole group is the whole number 0. 0 gets added in as a whole number, and then all of these are also whole numbers, 1 through infinity positive counting numbers. All right, your integers would include your whole number 0, your natural numbers, and any negative numbers, so like negative 6 or negative square root of 9, which equals negative 3. Notice the negatives on the outside. If it were the inside, it would be no solution, and that wouldn't actually count there. Negative 582. So any negative numbers. So your integers are all of your natural counting numbers, the number 0, plus any negative numbers. Negative numbers, however, are not whole numbers or natural numbers. So this is like bacon is everything, but this right here would be like beans, which is integers and rational. So negative numbers would be integers and rational, but they would not be whole numbers or natural numbers. All right, and then your rational numbers are any fractions simplified. So the fraction 6/8, for example, would be simplified to, we could divide by 2, so that'd be 3/4. So that's rational. Let's see. Any number that is a terminating decimal, like 0.25, for example, that would be rational. Let's see. Mixed numbers, 3 1/5 would be rational. It'd also be rational if it were improper. These rational numbers here, though, are not integers. So if they're a decimal or a fraction or a mixed number, they're not considered integers. Integers would be all of your whole numbers and natural numbers plus negative numbers that are not decimals or fractions. Your rational numbers can also be negative, so like this could be like a negative 0.25. So those would all be your rational numbers. And again, you'd want to fully simplify the fractions because they could end up being something like 8/2, which actually is equal to 4, and that's a natural number, a whole number, an integer, and a rational number. So 8/2 ends up being 4, which actually is all of these things, but 6/8 simplifies to 3/4, which is just a fraction, which would be considered only rational. Any decimals would be considered only rational. All right, so irrational numbers, well, the most famous one, of course, is pi. And because it is a decimal that goes on forever without a pattern. So that takes me to the pattern decimals. So if you have something like 0.12 repeating, 0.1212121212, that would be rational. If you have 0.12 6, 8, where just the 8 is repeating, so 0.6888888, that would be rational. So irrational numbers are decimals that go on forever without a pattern, like pi, because that's why people try to memorize as many digits of pi. It would also be the square root of any non-perfect square. So we know the square root of 9 is 3. That's a perfect square, so that goes over here in our natural counting numbers. It's also a whole number, integer, and rational. But the square root of 10, for example, is going to be irrational because it will be a decimal that goes on forever without a pattern. Same thing with cube roots of any non-perfect cube. We know the cube root of 27 is 3 because 3 times 3 times 3 is 27. So the cube root of 28, for example, would be irrational. It'd go on forever without a pattern. So it would just be keep going and going. So any decimal that goes on forever without a pattern, so like 3.46872 ... and it just goes on forever and doesn't have any repeating decimals or patterns, that is irrational. So any regular terminating decimal or a repeating decimal is considered rational. If the decimal goes on forever without a pattern, like you can't predict what the next digit's going to be and it just ends on your calculator because your calculator screen's too small, then that would be an irrational number. So hopefully this helps you with categorizing real numbers, rational numbers, integers, whole numbers, and natural numbers, as well as irrational numbers. You're going to try an activity after this to see if you've got it.